Assalamualaikum and hi, my name is Muhammad Isra bin Jaafri with matrix number 200673 in the course PHY4301 microprocessor and microcomputer. So in this video I will present about the instructions of EMU80X6. So for the next slide, this is the table of contents, and in this video I will present 5 instructions of EMU80X6, which is the first is data transfer instruction, which is with the code move, is instruction to transfer a word. And then for the second part, arithmetic instruction to perform addition, which is code add. And then for the third, data transfer instruction, code push, which is push the content of a specified register or memory locations onto the top of the stack. And the fourth is also arithmetic instructions, which is code sub, instructions to perform subtractions. And the last part, fifth, bit manipulation instruction, which is the code test, instruction to perform logical operation. So we will start with the first, which is MOV, data transfer instruction. These instructions are used to transfer the data from the source operand to the destination operand. Move, MOV. It moves data from register to register, register to memory, memory to register, memory to accumulator, accumulator to memory, and other example. In other words, it is used to copy the byte or word from the provided source to the provided destination. The destination operand can be any register or a memory location, whereas the source operand can be a register, memory address, or a constant or immediate. The 80X6 move instruction supports the following operands, which is as example, move AX BL, where the source is rec and destination is rec. Another example is move CX in a bracket 2341 with the source memory address and destination rec. And then another example is move in bracket 07012, AH, and the source is rec and the destination is memory address. And for the last example is move CS CX, where the source is rec and segment, the destination is segment register. So this the example of move instruction. This is basically the most basic instruction that we have to know. As you can see in this emulator, I have put move CX with hex value 037AH. This means that I have put an immediate number, which is 037AH, to CX. Next, the instruction I've put is move BX CX. This means that the any value of CX will be copied to BX as the destination operand. And as you can see at the results, we can get the value of 037AH at both CX and BX, which have successfully run by the emulator. Next, for the second part, we have arithmetic instruction, which is add. And arithmetic instruction are used to perform arithmetic operations like addition, subtraction, multiplication, and division. And in this part we will talk about add. The add instruction sums up to the contents of the source operand, which is the second operand, and the destination operand for first operand, and then places the results in the source operand. This instruction adds the data of destination and source operand and stores the result in destination. Both operands should be of same type of words or bytes, otherwise assembler will generate an error. It supports following operands, where in this example, we have add AX BX where the source is register and destination is register, and then we have add CL comma to the hash, the source is register and destination is immediate. And then another example is add in bracket 204ch comma and then L add in bracket BP, then in bracket again SI plus 23 comma DX where the source is register and destination is memory address. And for the example, these are the example of add instruction. It is quite simple and easy to understand. Firstly, we put at this example we put mov AX with hex value 1234 hash and then mov BX with hex value 5678 hash. To add these two, we put add instruction which is add BX AX where it will add the value of AX and BX. The value will be on the BX since it is the destination operand that we have made. But when using EMU80X6, we will get the value in hexadecimal, where you can see after I have run the emulator, the result which we get at BX is 68AC. So that's the simple add instruction that I have shown. Next, for the third part, data transfer instruction with code push. The push instruction push the data in the stack. Push, which sends, writes or move the content of a specified register or memory locations onto the top of the stack. It decrements the stack pointer by 2 and then stores the data from the source operand at the position of the stack pointer. The source operand can be a general purpose register, segment register or a memory address, but it should be a word. And then the content of the corresponding register is transferred to stack. In other words, the content of the corresponding register is sent to stack. Example of push instruction is push IP, push CSS, and push AX. And then we have push memory where the content of the memory is transferred to stack. And lastly, push F where the content of flag register is transferred to stack. Now, for the example, I want to show what will happen if we put push instruction in the emulator. So, at the left side, I have put mov AX 1234 hash where the value of 1234 hash will appear at AX. And now we have to observe the stack for the first part. Just for your information, stack will be always start from the bottom. And these are the logical address for the stack segment value from the stack. It will be 0100 and you can verify it at the register SS. And similarly, we can also get the value of stack pointer, the offset part of the logical address of the stack address, beside the stack segment which is FFFE, and we can verify it from the register SP. And every time we push something, this stack pointer will be decremented by 2. And how does this happen is we can see at the right side of the example. After I have put push AX, and then AX value 1234 will be pushed to the 0000 address right below it from the first part, and the value of stack pointer is decremented from FFFE to FFFC. So that's all for the push instruction. Next part, we have arithmetic instruction with code sub. Sub instructions basically subtract the number in some source from the number in some destination and put the result in the destination. Subtraction instruction takes two operands, which is subtract data in the source operand from the data of destination operand and then store the result back to the destination operand. Just like add instruction, both operands should be either in bytes or words. If one operand is in a byte and the other in words, then insert 2 zeros at the start of bytes, but they should be of the same type. The subtraction instruction support the following operands, where as example we have sub CHAL, where the source is register and destination is also register, and then another example is sub AX, 16H, where the source is register and destination immediate, and then another example is sub in the bracket SI, AX sub 19 in bracket PP, and then in bracket again DI, CX, where the source is register and destination is memory address, and the last example is sub AL and 10 in the bracket of CX, where the source is memory address and destination is register. So for the example of emulator for the sub instruction, it is basically the same like add instruction, but the only difference is it is for subtraction instead of addition. As you can see in the example that I have put, move AX with the value of 50 and move BX with the value of 20, and next I have put sub instruction, which is sub AX BX, where in simple terms we can be called as AX minus BX, which will be results in AX. So manually, if 50 minus 20, it will become 30, right? Then when I run the emulator, the final value that we should get in AX is 30, which are true, and that's how sub instruction works. And for the last part, we have bit manipulation instruction with code test, the instructions to perform logical operation. Test instructions and this the byte or word in the specified source with the byte or word in the specified destination. Flags are updated but neither operand is changed. The test instruction is often used to set flags before a conditional jump instruction. The source can be an immediate number, the content of a register, or the content of a memory location. The destination can be a register or a memory location. The source and the destination cannot both be memory locations. NCF and OF are both zeros after test, while PF, SF, and ZF will be updated to show the results of the destination, and then AF will be undefined. Now, for the example of push instructions, as you can see in the emulator that I've done, I move a binary number which is 00000101H to AL and test AL by 1, and then after run the emulator, AX value that we get is 5, which appear as hex number, and then the binary number is 0101, which equals to 5, means the test instruction never affect the operand. And then for the flag part, which is the 0 flag equal to 0, means that they are a matching of 1 in this test instruction. So that's all for the assembly language instruction of EMU8086 by me. So that's all from me. Thank you for watching.